Hello friends, today we are going to discuss about Drude theory. So before starting on Drude theory, we have to make some assumptions. So major assumptions of Drude theory are, so number one is that electrons have a scattering time tau. So tau is the scattering time of an electron. Okay, scattering time of an electron. So tau is the scattering time of an electron, and the probability that in a time dt it will undergo a scattering is given by dt by tau. Okay, so dt by tau is the probability that the electron will undergo a scattering in dt interval of time. Okay, dt time interval, it will undergo a scattering just given by dt by tau. Now the second assumption is that once the scattering has occurred, the momentum of an electron will be returned to zero. So once the scattering has happened, it will return to zero. Now the third assumption in Drude theory is that during the scattering event, the electrons that have a negative charge will interact with both electric field and magnetic field. So these are the three important assumptions of Drude theory. So first one is that the electrons have scattering time tau, and the probability that in time interval dt it will undergo a scattering is dt by tau. It is given by dt by tau. Now the second assumption is that within a time interval, once the scattering occurs, the momentum of the electron will return to zero. Now the third point is that during the scattering event, the electrons will always respond to the applied electric field and magnetic field. So these are the main assumptions of Drude theory. Now let's move on to the derivation of the Drude equation of motion. Now consider an electron with momentum p at time t. Okay, so consider an electron with momentum p at time t. Now let after a time t plus dt, the momentum becomes zero. Okay, because it undergoes scattering. Okay, so at time t the momentum is p, and after time t plus dt the momentum returns to zero. This is because they may scatter. Okay, and the probability that they may scatter is given by dt by tau, which is an assumption from the Drude theory. So momentum is zero, and the probability that it will undergo scattering is dt by tau. Now the probability that it will not undergo scattering is given by 1 minus dt by tau. Okay, so this is the probability that it will not undergo scattering. Now then we can find the expectation value of probability as, which is given by the probability that it will not undergo scattering, that is 1 minus dt by 2 into p of t plus f dt. Now this is from because f is equal to dp by dt, from there dp is equal to f plus dt. Now plus the probability that it will undergo scattering, that is given by dt by tau into 0. So these are the terms. Now this term will go because it is into 0, that is the momentum is 0, so this term will cancel off. Now we have to, next step is to open this bracket. Okay, so opening this bracket, we will get p of t plus f dt minus dp of t by tau dt. Now this term will give the equation dt the whole square. So this is a higher order term, so we neglect these terms. Okay, so we neglect the last term. So these are the terms that we get. Now taking this term to the other side, we get p t plus dt minus p of t, which is equal to, we take the dt common here, which will give by tau dt. Okay, so this is the term. Now we can write p t of t plus dt minus p of t as dp. Okay, which will give minus p of t by tau. Now this term, dt term, can be taken to the denominator. So this is the final equation, and this is the Drude equation of motion. And the solution to this can be given as, the solution to this is given by P of t, which is equal to P e raised to minus t by 2. P initial e raised to minus t by 2. This is the solution to this Drude equation of motion. This differential equation is this. The solution is this. Now this means that whenever an electron undergoes scattering, so after the scattering process, the particle will always lose momentum. Okay, so this is the conclusion which is drawn from this solution. Okay, thank you.